In example 4, Justin wants to line the perimeter of his patio with a paving stone border, so we have to figure out what it is. Kind of a strange shape for a patio, but let's go with it. Okay, so there's a bunch of information I don't know. I know this is 10.5 meters. I know this is 7 meters. I know this is 20 meters. I know this height is 15 meters, but that's not along the side of this at all. This is 62 degrees and that's 140 degrees. I'm thinking I'm going to have to make some right triangles and figure some stuff out. So I'm going to start over here. I have this 140 degrees, and this is a straight line, so I know that this straight line, if you remember, is 180 degrees. If this is 140, what's left over? 40 degrees. So that's a 40-degree angle. But I don't have any sides here. But I do know, and if I run this up like this, okay, now I look, I have a rectangular shape here. If this is 20 meters, from here to here is 10.5. That means this has to be 20 minus 10.5. That has to be 9.5 meters. Okay, so I have this. I have my 40 degrees. Now let's look at this triangle. This over here is the hypotenuse. This is making up the angle with the hypotenuse, so this is the adjacent. So I'm going to have to use cosine. Let's call this x over here. So I know the cosine of theta is the adjacent over the hypotenuse, so katoa. So the cosine of 40 degrees adjacent is 9.5 divided by the hypotenuse. So the hypotenuse, which is divided by x, let's just call that x right off the bat here. So that's x. X is equal to 9.5 divided by the cosine of 40 degrees. So x is equal to 9.5 divided by the cosine of 40 degrees, 12.4 meters. So I know that this, I'm just going to erase the hypotenuse and even the x, this is 12.4 meters. So now I've got this, I have the 10.5, I have the 7. Oh, I don't have this side here. But before I get there, let's go back. What else am I missing? Well, I know that from here to here is 7 meters, and from here to here is 15 meters. So from here to here is 7, from here to here is 15. So this has to be 15 plus 7. From here to here, which is 22 meters. But I don't know how long this piece is. Okay, so I can do that again. I'm going to use the 9.5. If I look at this, this is now the opposite. Let's call it y, is opposite that. And so I'm going to use the 9.5, which is my adjacent, and my y, which is opposite. So that's tan. So tan theta, so katoa, opposite over adjacent. So the tan of 40 degrees, I don't know what it is, but I know the adjacent is 9.5. So I'm dividing by 9.5 as the y is on the top, so it's 9.5 times the tan of 40 degrees. So y is equal to 9.5 times the tan of 40, which gives me 7.97, so that would round up to 8.0 meters. So I know this right here, and I think I'm going to erase this again, just to keep it kind of clean. This is 8.0 meters, so that means from here all the way to here, that would be 30 meters. So I've got this figured out. I have 12.4, this is 10.5, this is 7. Now I've got to figure out this side here. Let's call it, I don't know, how about B, and we'll call this E. Okay. Oops, I don't want that one. Sorry, I don't want to call that one E. I know what that is already. Drop that line back down. I need this, which is E. Okay, so for B, now let's look at this triangle. Here's my right angle. This is the hypotenuse. This is my angle, and you're like, well, I don't have any of these sides, but I do. I have this side because it's the same as this. This is 15 meters from here to here. So for B, let's look at what everything is. That's a hypotenuse. B is the adjacent. And 15, that's the opposite because it's opposite my angle. So let's go with B first. I have 15, adjacent and opposite. Again, that's tangent. Tangent of theta is equal to the opposite, which is 15, over the adjacent, which is B. B is on the bottom, so I have to divide. 15 divided by tan 62 degrees. And B is equal to 15 divided by the tan of 62. Oh, that's interesting. It's 7.97, so the 8.0 meters. It's not exactly the same, but it's very similar to this side over here. And now for my hypotenuse, so for E, I'm going to use this 15 meters still because it's given to me. It's more accurate than this, which I just kind of estimated. So let's replace B now. This is 8.0 meters, but I'm going to use this 15. So E, for E, I'm looking for the hypotenuse. So hypotenuse, opposite hypotenuse, that's sine. Sine of 62 degrees is equal to the opposite, which is 52, divided by the hypotenuse, E. E is equal to, it's on the bottom, so I divide 15 divided by the sine of 62 degrees. 15 divided by sine 62, and I get that that is 16.98, so about 17.0. So again, I'm just going to erase this and make this 17.0 meters. So here are the things I need to add up. I don't need to add up this 15 meters because I don't need that. I need this 8, I need the 7, 10.5, 12.4. We figured that was 30 and 20. So the perimeter, make sure you start at one point and go all the way around. I'm going to start here and go around counterclockwise. So 20 plus 17.0 plus 8 plus 7 plus 10.5. Just going to go down here, plus the next one is 12.4, and then plus 8 plus 22 is 30. And then I'm done. I've gone all the way around. Throw it into the calculator. 12 plus 17 plus 8 plus 7 plus 10.5 plus 12.4 plus 30, and I get a total of 104.9 meters. So the perimeter of his patio is right there, 104.9 meters.